Lesson 8. So, the binomial theorem. Okay, so I don't need to review this. We just talked about this yesterday. The Pascal's triangle pattern that comes from the FOILing out of x plus y to the n. Okay, so that same pattern we've talked about last time. Remember, make sure your row number, remember your row number starts with exponent 0. Just don't forget that. Okay, and then in terms of your combinations, they also start with combinations of 0. Okay, so it goes 0, 1, 2. So don't forget to count 0 is my point. And that's going to come up here in a little bit in terms of why the pattern changes. Exploring the binomial theorem. Referring to the combination array in the Pascal's triangle above, it's not just a coincidence that the combination symbols represent the numbers in Pascal's triangle. To investigate this, consider the expansion of x plus y to the sixth. So you look at x plus y to the sixth, we know by the Pascal's triangle that the coefficients come out as 1, 6, 15, 20, 15, 6, and 1. It says notice that each term in the expansion is a combination, okay, obviously you're focusing on the word there, combination, of x and y's. Consider how the third term, 15, x4, y2, is formed. It is formed by choosing a y from any two of 6 factors. I'll say it again. So it's formed by choosing a y from any two of 6 factors. Why are they saying 6? Right, because we know that it goes from 0 y's to 6 y's, right? There's no y, 1 here, 2, 3, 4, 5, 6 y's. So 6, it wants to know how to choose 2. Okay, so that's why it's 6 choose 2. This is interesting. 6 choose 2 is 15. Okay, 6 choose 2 is 15. So that makes sense because that's why there's 15 ways. Now here's the other part that's really interesting. Well, what do you think 6 choose 4 is? It's also 15, right? It's the other side. 6 choose 2 and 6 choose 4 are those symmetrical pieces. So they're both 15s. That's why it's got the coefficient of 15 for the binomial theorem, okay? So the 4x's can be chosen by 4c4 or 1, which gets you 6. So what they're saying here is that if we do 6 choose 2, to go first, we need 4 more, right? And we can only choose from 4 because we have to have 4. So I'm saying after you choose 1, 6 choose 2, the next one is, you know what it has to be, right? Because these have to all add up to 6. Okay, they all have to add up to 6. Okay, so that's why the last one's 4. If you're saying why isn't it 6 choose 4 like you said, I was saying if we decided to go 2 x's first, then it would be 6 choose 4 and then 2 choose 2 for the y's. That's all I'm talking about. Okay, so write the coefficients in terms of combinations. So we're going to write these coefficients in terms of combinations just for practice here because that's what we're going to today. So it's going to be this right here. If you look at the chart at the top right there, it helps you. It is 6c0, 6c0 x6, 6c1, it's kind of hard for me to write this in here, 6c1 x5 y1. It can. We can make it a little smaller. Just makes my writing a little bit worse. Plus the next spot. So we're here. 6c2 is this one. Okay. So now we're at the 21. So it's going to be 6c3. 6c3 x3 y3. And then it's going to be symmetric now, right? So it's a symmetric in terms of this next one, if it's 6c3, this is 6c2, this is 6c4, because 6c4 and 6c2 are the same thing. That's what I was telling you earlier. x2, y2, plus 6c5, x1, y, is it y4? Oh, sorry, yeah, y4. Thanks. Y5, and then 6c6 of just y6. Okay, so that's how you'd write in combination form. Okay, so we're doing this to kind of set up the binomial theorem, how we're going to use it in terms of the pattern of what to expect. Okay. Everybody can see that okay, that it's thinner? Okay. Good deal. All right. So coming up here. So it says the expansion of binomial x plus y to the 6 using combinations given the previous page can be extended for any exponent in the natural number. So what they're saying is this is a pattern. This is a pattern that we can use as a binomial theorem. And the pattern is, this is the pattern in terms of general terms. So you can see that kind of things to point out. So whatever the exponent is, that's the n you choose from. So our exponent was 6. We were doing 6 choose. Okay? Then it's whatever you're choosing, and then it's going to be essentially whatever position you're in. So this is kind of for position. Okay? So you always start with 0, then you go to 1, then you go to 2. Okay? X to the n, so you have your x to the n, your exponent of x there. Okay, and then you kind of see how it operates here. N minus 1, y1, n minus 2, y2, and etc. So this is the general form, which is our binomial theorem for pattern of terms. So remember in Math 20, we talked about general term a lot. Like what's a general term for the geometric sequence? What's a general term for the arithmetic sequence? This is a general term for the binomial sequence here for the theorem. So let's just apply this so you can see kind of what's happening here. So you leave the formula right there so we can see it. So what it's going to say is your example, determine the fifth term of x plus y to the eighth. So we're just finding the fifth spot. Okay, so we're finding the fifth spot then. We want to identify things in this way. What is the k? What is the n? The k is a little bit tricky because see the k there? The k is always going to be what? So we start with what number for our combinations? 8. No, which one do we start with? 0. You start with 0, right? Your first one is 6, choose 0. I'm talking about k right here. Oh, yeah, no. N is 8. N's 8. That's the easy one, okay? But my k, what I'm saying is, if you start with 0, and I want the fifth term, then what spot do I want? The fourth. So, okay, so we want the fifth term. Right, we want the fifth term, so we want 0, 1, 2, 3, we want the 4. Because that's the fifth spot. Okay? All right, so that's my k and my n. So now we can plug it in and we can go. So here we go. It's going to be k plus 1, right? That's why they say k plus 1. Okay? So k plus 1 is we want t of 5 equals 8c4 times x to the 4, 8 minus 4, y to the 4 by the pattern. And we're going to simplify it. So 8c4, if you calculate it, is 70. So this is 70. 8 minus 4 is 4. It's x4, y4. That's your fifth term in that one. Where's k what? Okay, k is 4 because you start with 0. So if we want the fifth term, 1, 2, 3, 4, 5. So it's always one back.
Can you just like look at
right.
the formula like k plus 1?
Exactly. Right. So k plus 1. So if k, exactly, that's what it says there above. So it says that on the top says, remember k plus 1 and not term k. So what that's saying is that, so if it's a fifth term, we want to do what we think, k plus 1. So it's like, let's see here. 4 k plus 1. Yeah. So we have to understand that the fifth spot is the fourth combination, like 4c. And then we need to add 1 to that for the actual location. So it's like they're one behind. So this k plus 1 makes you understand this is the fifth spot. But when you're doing the numbers here, it's obviously a 4 still. So it's kind of like, it's just like saying it's one back because of 0. It's one back. But anyway, so that right there is the fifth term in that expansion, 70x4y4. A couple things that's kind of interesting about that is that 8 even or odd? It is even, But in terms of the row number, where is the row number of 8? The 9th. 0, 1, 2 to 8, right? So it's the 9th. So the 9th is actually an odd row. Odd rows have dead centers. What I mean by that is this is dead center of the pattern of the triangle. How do I know that? Because they're matching. They're the same 4, 4. So it's dead center of the triangle. So you go to Pascal's real quick. We go up here and just look at, I just want to show you. See how these right here, sorry, this one right here, x squared, y squared, this is dead center for the 4. Because this is the 1, 2, 3, 4, 5th row. 1, 2, 3, 4, 5 terms. Right? So I'm just showing that you also feel good because you are dead center. Okay? So let's go look at the example now. The second one. So see, they say the middle term. So they want me to find dead center. What's the middle term of 10? Well, if it's 10, how many terms are there going to be? Right, you're 10, you're on the 11th row. So the 11th term, so you want the 6th. Okay, so you want the 6th is what we're looking for. So when you're doing this, what's my k? Good, Cash. K is 5. It's 1 back. It's kind of complicated in the sense that we're worried about 0 going down, and we're worried about 0 going across. So both times we have to account for the 0. That's why everything's bumped up. That's why you can keep getting off. That's probably why. Okay, and what's our n? Our n is still 10. And so now we can plug this in, and we can get what the middle term is, or the 6th term in row 11. Okay, row 11 of Pascal's triangle. Okay, when you do this, you're going to go 10C5. This is term 6. T6 we call it. Okay, term 6 is 10C5. Then it would be A to the 10 minus 5 and B5, right? 10C5 is 252. That's just calculating your calculator. And then you can see again, we figured this was going to happen, right? Dead center, they should match, A5, B5. Okay? Any other questions? Okay, so they want you to practice just doing it, for example, 2. They want you to write using the binomial theorem first. So that means with a combination. So I'm just going to go and write this. I know you guys probably know this just through the pattern because we actually have that 7th row written down. But they want you to practice the combinations. So what they're saying is it's going to go 7C0 x7 plus 7C1 x6 y1 7C2 x5 y2 7C3 x4 y3 7C4 x3 y4. Keep going here. Where am I at here? I'm at 7C4, so I'm at 7C5 x2 y3. No, y5, thanks. y5. And we got 7C6 x1 y6, and the last one 7C7 y7. Now, I'll just write here what the coefficients will be. I won't rewrite the whole thing. The coefficients will be 1 with these same patterns. So these, the x7, x6, y1, all this stuff, I'm just not going to rewrite it for time. Okay, 1, you're going to have that 7. You're going to have the 21, the 35, the 21, oh, sorry, the 35, the 21, the 7, and the 1. So that's the pattern of the coefficients when you do those combinations. So essentially what I'm telling you is, and you should know this, 7 choose 0. There's only one way not to choose anything, right? So that's always a 1. Everything choosing a 0 is a 1. That's why the 1's the outside. 7 choose 1. Okay. 7, there's 7 options to one thing. Okay, so I'm saying is these coefficients are the answers to those combinations. All right. And then if you think that was confusing, then you probably don't want to read the next line. The binomial theorem applied to more complex ones. Okay, yeah, so if that was a complex, we're going to go more complex. Okay, so says Susan was determining the fourth term of 2x minus 5. So what's changed is that we have some coefficients within the binomial. So we have to kind of keep track of that. So you see we have a 2x now and a 5. We don't have just x and y's. So it says Susan determining the part of her work is shown below. Complete her work. So it says we want the fourth term to be negative 20,000 x cubed. Okay? So the thing here, what's different about this than what we were just doing? Besides the numbers, but what's good? No y, right? We have one variable now. So that's why her answer is just different. Okay? Because that thing we were doing to the y's, we're going to do to the 5. Let me say that again. The thing we were doing to the y's, we're going to do the 5. So what I'm saying is, normally for 6, they want which term? The fourth term. So that's the fifth spot, right? So that means that spot is going to be negative 5 cubed. So you're going to be cubing an actual number now. So it's not just an exponent with a variable. Okay? You treat that negative 5 as your y, essentially. Okay? And that's what they did for you here. So look, x is 2x. Y is negative 5. The k is 3. Okay, k is 3 again because why? The fourth term, right? So it's 1 back. Your n is 6 because that's the exponent. So then here's the form. So 2x right there, the x. Negative 5 right there for the y. K right there, and right there. Okay, and then n right there, right there. Any questions? So you're just plugging in now. So what we're going to do now is we need to figure out what is 6c3. 6c3 is 20. You have 6 minus 3. A 2x cubed means 8x cubed. Do we understand that? You cube both pieces, right? And then you have a negative 5 cubed, which is negative 125. That's that's your first little simplification there. Now you multiply that all together, which is simply you just do a negative 125 times 8 times 20. That gets you negative 20,000. And that's your answer. So really, maybe you like the numbers better, less variables. Okay? Any questions on that one? All right, cool. We're just doing examples to finish out here. 4 more examples. The countdown's on. Okay? Okay, so here we go. Determine the fifth term. I'm going to pause the video. I want you guys to take a shot at it. This one does have a y in it. I want you to try to find the fifth term here. Right there, Donovan, you can finish. So okay, let's line out the things we need to know. So we need to know our x value that we're treating is 3x. Our y value is 2y. Okay, and we treat that as a negative 2y, but it doesn't really matter too much. Well, actually it might, because we'll see. You do have to put the negative in there because it's minus. K is 4. So k is 4 again because the fifth term, so kind of that's the 1 back idea again. And then the n is 7. That one's straightforward. Okay, so that means we want 7c4. And we want 3, whoops, not equals, times 3x to the, so it would be 3x to the what? 7 minus 4, so 3. And then it's going to be negative 2y to the 4. Okay, good. So that negative 2 will go away. And so this is kind of what Aiden was asking is, this is a value. You're going to cube a 3, and you're going to negative 2 to the 4th. You do times those coefficients. It is a bigger number. 7c4 is 35. 3 cubed is 27x cubed. Okay. Negative 2 to the 4th is 16y4. Now you multiply these 3 numbers. You get 15,120 x3 y4. Okay, good. That's all right. Okay, any other questions on that one? How do we do? Good, good, okay. All right. So applying it to where k is unknown, I have to do a little bit of solving. It gets a little more difficult. Okay, so we don't know what k is. They want us to solve for k. It's kind of like solving for the position. Alden has been asked to solve the following problem. One term in the expansion of x squared plus a to the 8th is that. 114, 688, x to the 4th. Determine the numerical value of a if a is greater than 0. Okay, so saying a is positive. Alden does not know how to proceed because he does not know which term he's looking for. Okay, his friend Griffin, nice friend, explains how to determine the value of k by showing him the following work. So, you still identify stuff the same. X is x squared, y is a, k is k, and n is 8. Okay, so we're going to go through that the same way. It says, since the term we are looking for contains an x4, okay, so that means the answer, right? The answer says, remember, I'll write it here since I went down, 114, 688, x to the 4th. So since the term we are looking for contains an x4, determine the value of k that satisfies this condition. So if we know the answer is an x4, what does that mean in terms of n, well, what's going on here? So do you guys see, let's look at a simplification here first. Let's look at a simplification first. So see how he put everything in and what he has. So he put everything in what he has. This 2, it distributed with multiplication there because power to power. And so he had 16 minus 2k. So this is what he has so far with the unknowns. So the point is, see this? X to the 16 minus 2k. This is pretty complicated in terms of like seeing this. 16 minus 2k should equal 4. Okay? Let me say that again. You put in the information that you have. Yeah, we're just doing normal solving algebra here. So we just minus 16. Negative 2k is negative 12. Yep. So x, or the k, sorry, this is k, not an x. I don't want it confusing there. Equals 6. Did I say it was 4? No, 4 is what the answer is going, like that's, we use that to figure it out. The 4, yeah. But k is 6. So now we know what k is. Okay. So now we know what k is. We can go ahead and write that in. So remember, we're trying to figure out like what we're looking at. So remember, if we got 6 for k, that means we're finding t of 7, right? Because 6 plus 1. We're finding t of 7, the 7th spot. But the 7th spot's going to be what? It's going to be a 6. A 6 choose. Or sorry, no, the 7th spot's going to be an 8 choose. I went backwards. 8. So what I'm saying is 0, 1, 2, 3, 4, 5, 6, and then 7. So 0, this is choose 0, 1, 2, 3, 5, 6, 7. I'm just showing you again, counting you up. That's why this is going to be 8. What's that? Yeah. Well, we know n is 8. They tell us n is 8, right? We know n is 8. I'm telling you the term number. Because remember, we're trying to figure out the term number. We just got k. So we just got k is 6. Equals 7. So we want the one with the 7, which is 8. The one with the 7th is 8 spots. So that's going to be 8 choose. If you look at all the stuff we did before, every time we had t is 7, t is 6, the thing we chose is 1 higher. If you look at the stuff we just did before. Okay? So what I'm trying to show you is we're going to be doing 8c. No, it's one more. So let's look here. Yeah. There's 2 more. Yeah. Oh yeah, you're talking about the choose though. Yeah. No, you're right. So we're getting to that. We're getting to that here. Let me put it down. You guys are on the right track. I see what you're confused about. Okay, so we have this. They're writing this out from stuff we already know. Okay, and then a to the k. But we know what k is. Okay, so it's going to be this. T of 7 is 8, choose 6. You said one less. Yeah, so you're right on that. X to the 16 minus, so if we know k, remember x was this, right? It was 16 minus 2k. So 16 minus 2 times 6. Okay, yes, which we knew it was 4, right? X4. And then what's the a? A to the, yeah, so just 6. All right, let's stop for a second. Okay, any questions? So so if we go one more step further, 8c6 is 28. So right now we're at 28x4, a6. Remember, a is what we don't know. We're trying to figure out a. And now we're going to solve for a. How can we solve for a? Well, we can solve for a, guys, because see this value here? We know this is what it's equivalent to. A is a number. It's no longer a variable. So what we're going to do is this equals that. And you're going to solve for a. Okay, so let's try it. So we have the beginning number of 114, 6, 8, 8, 8, x4 is equal to 28, x4, a6. We're going to divide the 28x4 over. Yeah, so the x4's cancel. What's the 28 divided there? Should be 496, 4,096. And so now we want to sixth root. When you sixth root, you should get plus or minus 4. However, we said it has to be positive. So a is 4. And so now we're done. So what we did was how the binomial theorem helped us was to help us simplify to what we expected to be there in terms of the missing variable and then solve for that missing variable. Okay? Last two here. Take it easy.
No, it's just gonna roll.
It hasn't even started. Okay, what's that? Yeah. All right. Determine the numerical coefficient of the term containing a7 and the expansion of 3 minus a to the 10th. So determine the numerical coefficient of the term containing the a7. So first off, where is the a7? Well, the a7 is going to be on the right side of the triangle, right? Do you guys see that? Because the a is in the what spot? The y spot. And the y's get bigger, right? So if it goes from y0 to y10, so I'm trying to explain to you in terms of understanding, you know, the second term, y0 is here, y10 is here. We're going to be right about here at y7 in terms of your terms. Okay, so we're looking for the y7. All right? So then what we know from that is we know our x is 3, our y is negative a, our k is k. We don't know our k because we're figuring that out because that's the term. And our n is 10. Okay. Okay, so then t to the k plus 1, we don't know what k is, so we'll just write that. That's fine. But we do know it's going to be, in terms of our formula, it's going to be 10c k. It's going to be 3 to the n minus k. And then it's going to be negative a to the k. If we fill in the stuff that we don't know. And we don't know what a is. Yeah, a is a variable. Yeah. Right, so we want A to have a 7. Right? So what does that mean? For what? Nope. If we just want it to be a 7. There's no other A's, right? So we want to get an A7. The only way I can get an A7 is K is 7. Oh, yeah, you're right. That's going to fill out the other stuff. Yeah, but this is just telling you K is 7. Because when you simplify that, that's not going to change. We need a A7 for the K. So you're thinking, they haven't told us a position here, so we don't have to worry about 0 right now. We're simply worried about when is A7. Okay, so one thing that's really important, guys, you guys are good job focusing right now, trying to figure out, well, we need to add 1 because of 0. We're not in rows right now. It just simply says the numerical coefficient of the term containing an A7. In order for the numerical coefficient term to have an A7, K has to be 7. It's just straightforward. K has to be 7. Because look at your form. That's a form that we're using the whole time. Okay, so K has to be 7. So then what that does is, so to what you're saying, Cash, that means we're looking at T of 8, K plus 1, right? So you're using all the stuff. You're still going to do 10 to 7, which is 1 less than the term, which we've talked about. That's what Ollie said a second ago. Okay, T. Okay, and then we're going to go 10 minus 7 for 3 cubed. Okay, and then we have negative a, not cubed, negative a to the 7th. Okay. Somebody tell me what is 10 to the 7th, like 10 combination 7? 120. So this is 120. This is 27. What's going to come out of here? A to the 7th, but negative. So we have to make sure we have that negative a to the 7th here, because that negative makes these negative. So your answer is 27 times 120 with a negative. This is the answer, because they want the coefficient. Negative 3,240. Okay, we got one more. And just to make Bobber even happier, we got a fraction one. Yes. 1 over x squared is coming. Yes. Yay. Finish with a bang. Here it is. Let's get it. Determine the constant term. So we're determining the constant term in the expansion. Okay, so to determine the constant term, so that means is somewhere something's going to cancel. That's what they're saying. Somewhere something's going to cancel. Okay. This is it. This is actually a tough one. It's good. All right, so let's go through first. X equals 2x, my first term. Y, negative 1 over x squared. You could think of that as negative x, sorry. No, that's right. Negative x to the negative 2. We don't know k, right? And then n is 15, because the 15's at the end of the top there. All right, so we set up everything without k again. So it's going to be 15 choose k times 2x to the 15 minus k times, I'm going to put it, well, I'll just leave how they have it. They leave it in fraction. They left it in fraction. Negative 1 over x squared to the k. Okay. Okay. Sorry, I changed that. So a couple things. What I think I would do is I want to get these. This is a little bit interesting one. I do actually want to write how I was going to, because if I get them to be 15 minus k negative x squared k. We could write this in so, all right, let's think about this here. Right, where? Oh yeah, -2, thank you. Okay, good. So what I'm trying to point to out, trying to explain to you here the best way I can, is I see that there's two x's there, so I'm really close to same bases. And so what I want to do is I want to break these up so I can get those x's together. So how can I break these up? So what would be the rule if I want to write this 2 separate from the x? How would I write that? What's that? Nope. Good idea, though. So what does the exponent do to the stuff inside? Does it hit everything or just one of them? Hits everything. So to separate it, I'm going to write it as 2 to the 15 minus k, x to the 15 minus k. I'm going to do the same thing. And then why is there 2 things in the second thing I'm going to do here? Because there's a -1. So I'm going to go times -1 to the k times x to the -2k. So I times the -2k there. This reason that's helpful now is so that I can put those as one term. I just do these together because they're the same base. So now it's going to be 15 ck 2 to the 15 minus k, -1 to the k, and then it's going to be x. And then I add the exponents. 15 minus k plus a -2k. 15 minus 3k. So let's pause there. Any questions how to get there? Why we did that? So let's just talk about in general. Why are we trying? This is a super high level question. This is really difficult. I get it. Why are we trying to do this right now? Like, what's the point? What's the question asking? So it says that there's a constant term, which signifies that what happens? Right. The x's go away somehow. And so what we're trying to do is we're trying to figure out how these go away. So in terms of an exponent, what exponent would make this go away? No. X to what power would make your x go away? 0. Right, because it'd be a 1. So we want to solve for when k is 0 here. Or what makes that 0 for k, I mean? 5, correct. So we want k equals 5. All that work was to figure out the k we wanted. Because we want to figure out what exponent makes that go away. If you don't see where that came from, what you're doing is 15 minus 3k equals 0. You solve. K is 5. So k is the value we want, where the x's will go away. If the x's go away, we just have constants left. That's the point. Yep. Now we're gonna do. We know what k is now, right? So that means we're doing t of 6 equals 15. Choose 5. Okay. 2 to the 15 minus 5, -1 to the 5, and then this goes away, so we don't have to worry about that. That's going to be your constant. So this value, 15 choose 5, is it 3003? 15 minus 5 is 2 to the 10th. 2 to the 10th is 1024. And then -1 to the 5th is a -1.
How come when you plug it back into the original, the values are still x?
Well, yeah, this right here. You're saying why is that there?
No, let's go back to the very start.
Yeah.
Plus 5
In the very start? Yeah, they should. Yeah. So yeah, if you put the 5 in the start, it should work too, in terms of what's left over. Okay, so then this multiplied out for your answer, it's quite big. 307,507.2. So 3,075,072 negative is that constant. All right, that's it.